All right, 1-7 functions. Functions, there we go. Starts with fun. So what I'm going to do for our notes today is I'm going to kind of go through what is not a function, and then therefore when you see something, you'll be able to say, well, it either fits or doesn't fit that, and then it will be a function if it's not. So let's say, let's look at a mapping. Okay, and I'm going to do something like that. Now, it doesn't matter what's over here. It only matters what's on the left, what's in the domain, what are the x values. And if you see more than one coming out of the same number, that is not a function. Not a function. Okay? For something to be a function, it has to basically have a definite place to go. If I start here at 2, I have options. Functions don't have options. Functions are predictable, functions behave well, and when you have 2 arrows coming out of the same starting place, I don't know what to do with that. Okay? Now, it doesn't matter what's over here. The arrows could all go to the same place over here. That's fine. In the range, that doesn't matter. So as you're just looking at the domain here on the left, and if 2 come out of the same, then that's no good. Okay? Let's look at ordered pairs. Or let's do a table actually next. So if we have a table, I'm going to kind of do the same here. If you look down the x's, and the y's don't matter. If you look down the x's and you see the same number twice, that's not a function. So look right here. If you see the same number twice, that is not a function. Okay? That's kind of like the same thing over here. I had a couple things starting at 2. Well, if you have more than one place starting at 2, you know if the function starts at 2, I don't know where to go. Do I choose this 2 or do I choose that 2? So it's kind of the idea behind it. Definitely not a function for those. Okay, I'm going to scooch this up a little bit. I'm going to try to keep my notes in the top half of the screen as much as I can so that you can actually see as I write. So let's look at ordered pairs. Okay, and let's try 1, 3, 2, 6, 3, 5, and 2, 7. Okay, and let me scooch this up now. And this is also not a function because look at the x's. You have 1, 2, 3, and 2. Because these two match, this is not a function. Okay, so because those two match, that is not a function. Let's look at one more graphically. Now try to scooch that up, not too far, leave that there. So if we look at a graph, we could have a graph that has a line or some points. Let's look at a couple of points first. And sometimes we call this the vertical line test, where if you draw a vertical line and it hits a point more than once, this is not a function. Okay, and I can do the same thing if I have an actual solid line. So let's say I have a graph, and these graphs kind of look funky. Normally, like a line graph would just go across the page. If you have something weird like this, like a circle, this is not a function because if I draw a vertical line up and down, it'll hit it more than once. So right there and right there. So this is not as well. Okay, so basically I've shown you a bunch of not a functions. If it doesn't fall under what I've said here, then it is a function. So let's go back up to the top. Okay, if you don't have more than one arrow coming out of the same number, then it is a function. Looking over here, if you don't have the same number more than once in the x's, then it is a function. Looking at some ordered pairs. Well, look at the x's. If all of the x's are different here, then it is a function. So if that was 1, 2, 3, and then 2.5 maybe, something other than what would match over here, then it is a function. And the same thing down here. If I don't have two dots right above each other, or if I don't have part of the line right above another part of the line, then it is a function. Okay. I don't really want to try it. Try it for a couple right here. You'll have plenty of chances in your workbook to go ahead and try that. So I'm going to leave that for that. I want to look at one more thing here. This is usually when we talk about functions, we talk about doing some math, some arithmetic, and so that's what we are going to look at next here. So sometimes we have this notation. Looks like f of x equals 2x minus x squared. Okay. Now I said f of x. That means this is a function of x, and f of x basically means you plug in numbers for the x. So I could say f of some other number. We could do that now. Let me see. Find f of, 7 is what I wanted. Okay, so what I'm going to do is I'm going to look at this, but you can see f of x here, and I want f of 7. So instead of x, I'm going to write 7. So f of 7 is equal to, I'm going to do the same thing over here. Instead of the x, I'm going to write a 7. When you're evaluating functions or expressions, it's usually good to put whatever you're replacing it in parentheses. So instead of this x here, I put the 7 in parentheses here. Instead of the x here, I put the 7 in parentheses here. Okay, so let's see. That equals 2 times 7 is 14. 7 squared is 49. And when you're subtracting in the wrong order, subtract in the right order. So 49 minus 14, 9 minus 4 is 5. 4 minus 1 is 3. And then make your answer negative. So negative 35 for that. Okay, that should be kind of familiar to you. I know most of your schedules you had pre-algebra before, so let's go ahead and try a couple here and see how you do. And this I'm going to throw a little monkey wrench in here, but let's see how you do. I'm going to say g of x is equal to 5 minus 2, 5 plus 2x. Let's simplify it a little bit. Okay. G of x equals 5 plus 2x. So what I want you to tell me three things. I want you to tell me g of 3. I want you to tell me g of 2x. And I want you to tell me g of x plus 1. Okay, so what I want you to do is replace the x with each of these. You're going to do 3 different problems with the same function. Go ahead and try that now.